Okay, so you guys have the you guys have the last homework as well as the final that has been given to you. So my plan is to quickly go over um, the last homework. Um, and then if you guys want, you can ask me questions about the final questions that you are having issues with, and then I will come up with like adjacent questions because I can't actually give you answers to the final, but I will give you guys similar questions that you guys can use as reference. So one is simple enough. The maximal order is going to be. What do you guys think the maximal order is going to be? Yeah, exactly. And it's pretty easy to find two examples of elements that are going to be of that order, and then you can just cross it with. You can find out how many elements are of. It's pretty easy to extrapolate from there to find the number of elements and to come up with a couple examples. This, I believe, is actually the generalization, I believe, is actually already in your notes, right? So if we have P1 to the A1, yeah, let's just do this as the product of 1 to n. How many different abelian groups are there of this size?
It's gonna be the number of partitions of A1.
Yeah, of our AIs. So at first I
Yeah.
wrote A1, then I changed it to AI. So the number of abelian groups of the size will be the product of the partitions of of our AIs. So that tells us that as long as we have the same AIs, it doesn't matter what P's, it doesn't matter what primes they're attached to. Does that make sense?
Yeah.
Cool. So Pete, does that make sense?
Yes.
Cool. So what does it mean? What do we mean when we say invariant form? Invariant factor form.
Isn't that the one where it's the z's are such that the next z the previous one? Or it's like a factor. So like the first one's gonna be the biggest and the second one's gonna divide the first and then the third's gonna divide the second and the first. Is that the
I don't think it has to divide it. Oh, actually, yeah, I guess it will divide it. Yeah, sure. So if we line up these guys, what do we get? We get, this is 2 squared. This is 2 squared. And then we get 5. So this is 2 squared, this is 2 squared, this is 5 squared, then we get 5, and then we get 7, right? So we can group these two guys separately, and then this becomes Z700 cross Z20, right? And Z20 is going to divide 700. Does it make sense what I did there to people? Lucy, does that make sense?
Yep.
Cool. And so do people have actual questions that they want? Have you guys looked at the final exam yet?
I have not. I have not looked at it yet.
Okay. Well, I don't want to have either of the other two of you guys looked at it yet.
Yeah, I have. Could you maybe talk about 6 a little bit?
6. Okay. So let G equal R2 be the set of all ordered pairs of real numbers under the usual addition. Let N be the subgroup consisting of the points the line y equals 2x. The coset 5, 0, 5 plus N is the line. The cosets. So what do okay, so how should I change this guy? So I'm just gonna change the line so that we'll be working with y is equal to 3x, and then we'll work with the point 0, 6 instead. Cool. So what does it mean to examine the coset 0, 6 plus n? It means that I'm looking at a whole new cluster of points, right? And what, right? So if I give me a point on this line.
1, 3.
Sure, yeah. So if I deal with 1, 3, and then I add 0, 6, what do I get?
1, 9.
Exactly. Cool. So what is going to be the equation of the line that links these two guys? Oh, sorry, not these two guys. These two guys.
So is it like y is equals to 3x plus 6?
Exactly. That's going to be the general form of the line that we're dealing with here. That's anything in this new coset is going to be of this form. Does that make sense?
Yeah.
So if I were to give you another point, say 4, 12, and I wanted to know, is this in the same coset or are they in distinct cosets? What do I do? So
Repeat the question again.
if I want to check if another point is in a given coset, what do I do?
You can just like multiply, or in this case, add the point to the coset and see if it gives you back the same coset?
Well, yeah, so I literally just plug it in to the equation that defines a given coset, and then I see if it satisfies it. So in this case, does 412 satisfy this equation?
No.
No. So then 412 would not be in the coset that is generated by 0.6 plus 3x plus y equals 3x. Does that make sense?
Yeah, I think this problem's kind of neat. It's sort of like looking at it, and it sort of reminds me of linear algebra, where you were like dealing with translations and such.
Yeah, this is a very similar concept there. Are the cosets equal or disjoint? So that basically answers these two questions. What is the group operation for the quotient group G over N, and how do we know that it is well defined? So what would this quotient group be? What do you guys think it is? I think you guys have dealt with a very similar question, or I think I might have given it in a previous example, or it might have been a previous homework, but we did something very similar with the line y equals x. And do you guys remember what we got when we dealt with the example y equals x?
Yeah, it's just like translations of a line.
Yeah, and it ended up being just equivalent to r under addition. So I'll leave that as the hint for this guy, for C. What is the identity element for this quotient group? Well, for this quotient group, it was just anything that was mapped to be by this line. So when we were dealing with the original quotient group, it ended up acting like 0 under R with addition, but the actual everything that got mapped to it was defined by our original, by our n. Our n was the thing that got mapped to the kernel, and in this case, it's y equals x. So I'll let you guys extrapolate what it would be for y equals 2x. And then define phi from, is this an isomorphism? Briefly justify your answer. So what would it have to be for it to be an isomorphism?
1-to-1 and onto.
Yeah, and it would also have to preserve the group structure. I think you guys can see that it'll still be 1-to-1 and onto pretty easily, right? I mean, it'll either expand or compress it by a factor of 2. I'm pretty sure compress it by a factor of 2, but that still works. R divided by 2 is still going to be, or if you scale everything down by a factor of 2 under addition, is still going to be a group. And then, so it basically just comes down to checking that the algebraic structure is preserved, that the, what's it called? That there's still something akin to addition. And you should read this guy. It's not actually specified, but read it as the real numbers under addition. Does that make sense?
Yes.
Cool. Yeah, sorry. I don't want to go much more in depth and just straight up give you guys the answer. but I think that that should put you guys heading in the right direction. Do people have other questions that they?
Yes. Could you go over 4?
4, okay. Find the external direct product of cyclic groups of prime power ordered that this is isomorphic to G. Okay, so I don't remember if this is definitely the external direct product, but I believe that this is it. So if I were to give you Z to the 54 cross Z to the 6, I believe that the external direct product would be, I would say, what is the prime factorization of this guy? That's 3 cubed times 2. So it would be Z to the 27 times Z2 times Z3 times Z2. Is that correct? Is that the meaning of external direct product?
I think so. I think
Yeah, that's the problem. I'm not sure because I kind of did mine like that too, but I'm not sure whether that's the external direct product.
I believe that it is, but let me look this up to verify. External direct product is used either of groups under the operation multiplication or that was not helpful. Wolfram Alpha has failed me. Okay, the external is a finite collection of groups. Yeah, yeah, that's good. Yeah, so that can be very naturally extended. That should be the right method. And you just do the prime factorization of each of these guys and extrapolate from there. And then for B, how many different abelian groups up to isomorphism have this order? And then that is going to be basically the same thing as using the same theorem that we referenced here, that it's just going to be the number of partitions of 3 times the number of partitions of 4, because it's just the different number of ways that we can partition these powers, right? Does that make sense to people?
Yes.
Okay. Any other requests?
Maybe like look at 5. Sorry.
5?
Yeah.
Yeah, so
is that under addition? Like the Z31 to Z31, are those both addition?
yeah, they're both addition. It's just we have some map that sends 16 to 19. And 16 was actually picked to be pretty nice here. What is 16 plus 16? Mod 31.
Just 1.
Yeah, and so that tells us that phi of 16 plus phi of 16 is going to be equal to phi of 1. That's going to be equal to 19 plus 19 mod 31. And then once you have this guy, once you have what phi of 1 is, it's really easy to calculate whatever else you want just by multiplication and then modding it out. Does that make sense to people? If not, I can give a different but related example.
I think it does. Yeah.
Who was the one who asked for 5?
Me.
Does that make sense to you?
Yes. Thank you.
Okay, cool.
I had one as well. Can you just remind me for 7, like what it is that we need to show to prove that it's cyclic? I mean, without giving us the whole answer, I guess.
Okay, so if it's not cyclic, then that tells us that we need more than one element to generate it, right?
Yeah.
Okay, so if that's the case, then I can create 2 subgroups generated by 2 distinct generators, right? Or not quite generators, but if I have a list, so if not cyclic, then need at least 2 elements to generate the group, right?
Mhm.
What can I say about the order of those 2 elements? As it relates to the order of the full group. Well, first off, if I were to just generate, like just apply them to themselves a bunch of times, that would form a subgroup, right? Lucy, right?
Yeah.
So what do I know about subgroups, the order of subgroups?
Sorry, I'm blanking on this.
I just want to say that the hint is like everything.
Yeah. So there's a relationship in terms of the order of subgroups to the order of the whole group that has to do with prime numbers. And if you should be able to Google the rest.
Okay, thanks.
I don't know how to give you any more without actually just giving the answer.
Right, yeah.
So any other questions that people have?
Just one more. This is more related to the grading. Since the midterm grades are back, I didn't realize he didn't write, I don't think, on there that we were gonna only be graded on 5 problems out of 6, but it seems like we were. Do you know if he plans to do anything like that for this? Like maybe we get graded for 7 out of 8 or something?
Not that I know of. So I like the really nice thing about 5 instead of 6 is that 5 is more easily divisible into 100. Like that just makes everything a nice clean 20 out of 20 or 20 point question. 7 is not a nice number in that regard. And I don't think that he'll drop it down to 5. So I'm guessing that this is actually going to be every question is worth either 12 and a half or 13 points. That would be my guess, but he has not given me any specific information.
Okay, thanks.
Do people have anything else that they want to ask? Michael? I think you can quiet. I could not understand that.
Oh, I said I was just taking it all in. I don't have any specific questions right now.
Okay, cool. So
Wait, can you scroll up to the top? I want to see what the question, like what the top questions are, or like the first questions are. Okay, cool. Thanks.
yeah, yeah. So this guy right here relates pretty closely to a question that a lot of people got wrong on the midterm. A lot of people claimed that when we had what it was I pi times an element of the rationals, that all of those guys were going to be of infinite order. Actually, all of them are going to be of finite order, and they're going to be finite order of. You're just basically going to want to look at the reduced form of the rational number that you're working with, and that should tell you the order of the element that you're working with.
Wait, I have a stupid question, but how do we see like feedback if we got any on assignments and exam, and the midterm?
I think that if you just open up that assignment, it should come up. I haven't tried looking at it from student view. Does anyone else know?
Yeah, usually if you just go to the gradebook on Blackboard, there will be like a comment bubble next to your score. And if you click on that, it'll tell you a breakdown by question of what you got points off on.
Okay,
Okay, thank you.
cool. So if no one has any other questions, then I'll let you go. But I think I've given him.
TAing for abstract algebra 2? Are you TAing for abstract algebra 2 next term?
I have not gotten my teaching assignment yet, so I don't know. I'd say that me and the other person are the most likely candidates, but it's far from a guarantee. Like when I've done the statistics course, I've been put on part 1 and part 2 separately, but not in sequence.
There's actually no recitation listed for 332, so we might not have any recitation TAs.
Okay. Yeah, that might be the case. Yeah, I'm sure that, yeah, because you guys would have had to build that into your schedule if that was needed, but it does seem strange for them to have the recitations for the one section, but not for part 1, but not for part 2. So
That's what I thought.
Okay, cool. So if no one has any other questions, I'll let you guys go.